Hi folks, welcome to day 22. Today we're going to be talking about section 5.4, which is all on solving equations with rational exponents. So now that we've had more practice with equations that have radicals in them, today we're going to be practicing with some equations that contain rational exponents. Remember that you can always treat your rational exponents as roots, which is why we can rewrite rational exponents as radicals and vice versa. So that means that when we're going through and trying out these problems, we can follow those same three steps. Isolate, but instead of isolating the radical, we're going to be isolating the term that has our rational exponent. So in something like y equals 2 times x minus 5 to the 1/2 equals 6, in this case, what we would consider as the radical would be everything that I have highlighted. So everything that's being raised to that rational exponent power. All right, so your first step is always to isolate. Second step is always exponentiate. I realize now that I'm not sure if that's how you spell exponentiate, but that's okay. Go with me. There's a reason why I'm not an English teacher. So when you're isolating, you're following those same steps, making sure that you are adding or subtracting anything that's being added or subtracted first, and then multiplying and dividing as needed. Similarly, when you're exponentiating, we have to remember to still do it to both sides of the equation. But the biggest difference is last time we said, okay, well, we exponentiate based on the radical. Well, last time we had like a square root, right? Which we were then able to square both sides. But in this case, we don't have a square root because we don't have any roots. But what we can do, right, if we had something like x minus 5 to the 1/2 equals 3, if we were to exponentiate both sides, we are going to exponentiate the reciprocal power. I'm just going to call it exponentiate using the reciprocal power. If you don't remember what reciprocals are, it just means that you're taking a fraction and you're flipping it. So you flip your fraction. In this case, since we have 1 divided by 2, I can go ahead and raise both sides to the flipped fraction of 2 over 1, which is just 2. All right, so when you exponentiate, you're going to exponentiate using the reciprocal power. So go ahead, take whatever your exponent is, flip it, and that's the power that you're going to raise it to. All right, so isolate, exponentiate, and solve. Same 3 steps. That's what we're going to be doing today. Let's find out a few examples. All right, so if we have 2 times x plus 2 to the 3/4 power plus 4 equals 20. Our first step is always isolate, exponentiate, then solve. So first step is to isolate. I know that I have to get this x plus 2 raised to the 3/4 power. That's what I'm getting by myself, like by itself. That's what I'm isolating. If it helps you to draw a little box around what you're isolating, you can do that. Doesn't bother me. All right, whatever it takes to get this to make sense to you. So isolating. All right, we're going to start by first adding and subtracting anything that needs to go away, and then multiply or dividing. So here we have this plus 4. So in order to get rid of it, I'm going to have to go ahead and subtract 4 from both sides, since that's the opposite of addition. When we do that, we're left with 2 times x plus 2 to the 3/4 power equals 16. So I have now gotten rid of that 4, which is great, but I still have this 2 that I got to get rid of, right? Because the only thing I care about is this x plus 2 to the 3/4 power. So since I have 2 times that x plus 2, I'm going to go ahead and divide both sides by 2, since that's how you get rid of that multiplication. And then we're left with x plus 2 to the 3/4 power equals 8. So now we have isolated. Excellent. In fact, most of you are probably doing a pretty good job at isolating right now because we are in quarantine. I'm sorry, bad joke, but you don't get to see me in class, so I have to make terrible jokes virtually. All right, we isolated. Second step, exponentiate. So we're going to be exponentiating based off of that reciprocal power. So since our power is 3/4, reciprocal means we're flipping it, so what's in the denominator comes up, and what's in the numerator goes down. So our 3/4 becomes 4/3. So we're raising both sides to the 4/3 power. Now, the reason why this works is if you think back to our last unit when we talked about exponent properties, when you have something like this, right, we have the power of another power, so those would be multiplied. And when you multiply those, you multiply your numerators, so you have 3 times 4, divided by your denominators, which is 4 times 3. So you have 3 times 4 divided by 4 times 3, which is just 12 divided by 12, or 1. That's why they cancel out. That's why you have to use the reciprocal power. You can't just make up some numbers and say, yep, they cancel out, because that's not how it works. The reason why these cancel is because when you multiply them, we get 3 times 4 over 4 times 3, which is equal to 1. All right, a 1th power is like the basics, right? It's like the complete base of everything. So that's what we're trying to get everything to. All right, so on the left, because our exponents cancel, we're just left with x plus 2. But on the right, we have this 8 to the 4/3 power. That doesn't really help us. So in order to solve, we are going to have to rewrite our 8 to the 4/3 as a radical. All right, we're going to do that because it doesn't make a whole lot of sense to raise 8 to a 4/3 power. You can't easily do that in your head, and I'm all about trying to teach you ways of doing mental math so you don't have to use a calculator. All right, so we know that anytime that we have a rational exponent, that whatever's in the denominator, right, of the exponent, what's in the denominator is down in the dirt with the roots. So that means that that root goes on the outside. And what's in the numerator is, remember, so that's like above the dirt, that's up with the flowers, and that's where we have our power. So that's going to be our power. So we still have 8 in the middle, right, because that's still our base. But we have a power of 4 over 3. So our denominator is 3, so our root is going to be 3. And our power is going to be 4. And in this case, I'm going to go ahead and put parentheses around because it's going to make it a lot easier for me to go ahead and evaluate that. All right, so now we have x plus 2 equals the cubed root of 8 raised to the 4th power. And the reason why we did this is because the cubed root of 8 is a really nice number. It's just 2. So then we have 2 raised to the 4th power. And 2 raised to the 4th power is 16. So now we have something that's a lot simpler. So we can finally do step 3, subtract 2 on both sides. We get x equals 14. We've now solved for x. Excellent. So again, we went ahead, we had to isolate, right? So our isolation started up here, continued on down here, and then by the 3rd line, we were finally fully isolated. Then we exponentiated based off of that reciprocal power, which is what we did in that 3rd line. All right, and then the rest of it was just solving. Isolate, exponentiate, solve. All right. Let's go ahead and do one more. All right. So if we have something like 3x to the 1/3 power equals -3. So we know our 3 steps are to isolate, exponentiate, and solve. Here, we already have our exponent, like our what we're exponentiating, what would be a radical. We already have that isolated. So we already did step 1. Step 2 is exponentiating. And it's really important when you're exponentiating that you are putting your parentheses around each whole half, right? And that's why it's really important that you can't exponentiate before you've isolated. You have to isolate first, because otherwise you have to worry about the foiling, which would be much more difficult. But we can go ahead and exponentiate this, and we're going to exponentiate it based off of its reciprocal power. So since we have 1/3, the reciprocal would be, since we have 3 on the bottom, put 3 on the top. And since we have 1 on top, put the 1 on the bottom. So we're going to raise both sides to the 3/1 power, or the 3rd power, which is the same thing. So when we do that, our exponents on the left cancel. So we have 3x, and then we have -3 cubed. And -3 cubed is -3 times -3 times -3, which is -27. All right, so it was already isolated, we exponentiated, and now we solve. So we have 3x, so I'm going to go ahead, divide both sides by 3, and I get x equals -9. All right, I've told you a couple times in this video that you can use, you can treat our rational exponents as radicals because they're the same thing. Well, this is actually a really great example that shows that, because we have 3x being raised to the 1/3 power. So if we were to rewrite this as a radical, I know that I have 3x on the inside, and I know that my power is 1, and I know that in this case, since my denominator is 3, denominator is in the dirt with the roots, so my root is 3. So we could have had the cubed root of 3x equals -3, right? And if we were to do this using our skills we learned yesterday, we know that we already have it isolated, so then we have to exponentiate by raising it to the radical power. So you can see we actually end up with the same answer, because we get 3x equals -27, or x equals -9. So I just wanted to take a quick minute to show you that, yes, I am actually telling you the truth when I'm saying that these things are the exact same. You're just treating them differently, right? There's different uses for different, like you have different times you're going to use each of these. Sometimes you're going to want to use radicals because it makes them more easier, right? When we, up here, when we changed our exponent into a radical, we changed that because it's a lot easier to do the cubed root of 8 rather than 8 to the 4/3 power. That doesn't make sense, right? So sometimes you're going to want to use exponents, and sometimes you might want to use radicals, all right? So for these problems, I would recommend, most of them are pretty difficult, like you won't be able to just change them into radicals as easily. So if it has, I will say, like, you are welcome to use radicals if you want to. However, I would caution you, because if we had like a squared here, right, if this was like a 2/3, that would make it a lot harder of a problem. So if you have like a 1/3 or a 1/4 or a 1/2, like anything 1 over a number, you can change it into radicals if you prefer the radicals. But in general, if you're given a question and then as an exponent, a lot of times it's easiest to keep it as an exponent. That doesn't mean that you might not, that doesn't mean that you're never going to use this, but anyway, that's all I have for you today. Best of luck on your assignment. Go ahead and try that out. Tomorrow we'll be working with some more challenging radicals. Thanks for watching.